Colin, I'd love you to just expand a little bit, maybe on like how the lower level protocols will enable additional services or
Kier
functionality.
touched on it a little bit. Like, I mean, basically, one of the main philosophies here is to start to, how do I say it, provide value in the outer industry. So, I mean, one of the ways that we provide value is producing, high efficiency computing systems. Like, I mean, we've got the lower level protocol, which is kind of a template protocol, which allows, I mean, I created it just out of necessity because I'm like, well, I have to write these two protocols, and the servers are very similar, so why don't I just write it using polymorphism in C++? And so that's how I started out with that, and then it started growing, okay, a template database, everything like that. So with these templates, what we're able to do is we're able to produce new, I guess, baseline infrastructure that's going to enhance the efficiency of the internet as we know it. So with the protocol, it handles, 5,000-10,000 connections, not a problem. I maxed out, like, I had 6 VPSs pushing to 1 VPS. I maxed out the bandwidth on all 6 of them, and it still was, running stable. So that's kind of what I've been working on, is simplicity, because I believe a lot of the internet has become a little bit overcomplicated. These things have been built and built on and built on and built on, and kind of like Patrick said, even with the blockchain, it's like we haven't really worried about this architecture on the lower levels that actually needs to be built strongly, because, I mean, to build a building strong, you have to start with a wide foundation, and you have to grow it out, but we've kind of been doing it opposite. And so the internet, it works, but a lot of some of the old threading models and even like network time protocol, I mean, a lot of these things were just kind of built in the 80s and the 90s, and the internet's grown and boomed, and, I mean, people kind of neglected some of these lower level infrastructures. So that's part of it with the lower level database, the lower level library, I mean, and eventually getting into our own encryption systems. It's going to be quantum secure beyond just ECC, which is elliptical curve cryptography. I mean, we're going into more, I'm working on, I guess I can introduce the basic concept of a calculus-based encryption system where you use indefinite integrals to create your public-private key pairs, and then you use derivatives in order to create your public key, since your interval and your integral, is never going to be known. The C is never going to be known. So the more, times that you derive this equation, quote unquote, then, and the larger range you allow within C for the interval, then the more secure your encryption can be from 2 different angles, from 2 dimensions, essentially. So that's another one of the things that I'm working on, because really we are facing some massive changes in the internet, not only just in blockchain technology and distributed consensus and peer-to-peer systems, but we're also going into new computing systems like quantum computers. There's the 5-atom quantum computer that's coming out now, which, it's pretty incredible what we're able to start doing, but if we don't catch up with the software side and make that more secure and more stable, then, it's kind of, I don't know, the Moore's law and the increase of computing power is kind of a double-edged sword, because yes, we can do more, but then if your computer runs so fast, why optimize the algorithm? Until, we get to a point where it bloats up so much that we're like, well, we need to kind of design this, but wait, now we're 2 million lines of code in, and we're going to have to change millions of lines if we want to go down to lower levels. So that's why I developed these templates with the lower level library, which basically they are kind of a toolkit, just kind of like what Nexus is going to be with, the service templates, where, current is one of the service templates, and then there's the selection and the voting and the hosting and all these different things that, I mean, they're kind of, we need to have different ways in which we can build something. We need multiple tools, multiple things. So that's one of the main things as far as the computing systems that we're addressing with Nexus. And, like I said, the really big philosophy here is, we're trying to provide value in the outer world, not just in Nexus. And that creates an indirect reflection where, as we provide more value into, let's say, somebody's new system, where they can use less computing power, they can scale further as, the population grows and computing systems get more complex, then that's going to provide value back on Nexus, because people are going to say, where did this come from? Well, we're producing it to help, enhance the internet and help enhance computing. Kind of like what Linux did with open sourcing operating systems, where, all we really had before that was, Unix, obviously, which is what Mac was based off of, and Linux, and, Windows, which, it's hard to really have transparency. So that's another point of value that we're contributing, and especially even in the blockchain architecture, like Patrick was mentioning, is we can basically be, I guess, handling the lower levels and rebuilding some of these lower levels in the blockchain as well, because the blockchain can't really scale as it needs to support a mainstream adoption. Bitcoin's pretty much bogged down already. It's like blocks are pretty much a megabyte already. So the more that people start adopting it, the more we're going to get backlogged, and that's going to reduce the morale, essentially, which is something that, you know, it'll work for a point, and it works for a time, but, you know, unless we rebuild this foundation, it's going to crumble the larger we try to build the system. And so those are a lot of the different pieces, I guess you could say, that are going together into this project that, you know, in hopes that other people will find that valuable as well. And, you know, let's say Bitcoin with, you know, the Merkle trees and different things like that, that are not Merkle trees, the Merkle chains that we're building on, you know, is the layers of the chain, you know, tiers, so that it can handle kind of organic transaction processing. Because, I mean, yeah, we can increase the capacity of the network, but why reduce the efficiency to increase the capacity when the capacity may not be needed? So,
and for Colin, how are the dev funds being managed? Your decentralized dev fund.
Yeah, well, there's 26 keys, there's 13 ambassador keys, and 13 recycler keys, or sorry, developer keys. So what's happening with those is the ambassador program is kind of like a decentralized trust, if you can see it like that. And it basically, each key holder is going to have a specific, I don't know, purpose with it. So, you know, I mean, Nexusoft is going to, you know, manage one key. You know, the technology company I'm working on later down the road is going to manage another key. You know, what's it called? Vector Space Systems is most likely going to be handling another key, depending on how that goes. And so basically, if you think about it, all these there's a lot of beautiful things that we can do as we start to be able to create this new prosperity-based economy. We also want to be able to share that prosperity with other people by solving some of the issues in the world that we have at large. Like, I mean, we have water issues here in Arizona. I mean, we've got maybe 5-10 years left of water. You know, alternative energy systems, we're not really doing it in an efficient way. Another one is, you know, I mean, getting some of these satellites up into space. Another one is, you know, continually growing the software development company, which is going to provide more real-world value. Another one is localizing agriculture. Another one is increasing architectures, you know, I mean, making houses more underground, more beautiful to allow the earth to do what it does, but also us to do what we do. So there's a lot of different movements, and that's part of the providing value in the outer world rather than, you know, just in this industry. And that's what the Ambassador Decentralized Trust Fund does. And that actually is a piece of a voting group, just like there's the developer keys where, you know, developers that become dedicated, they don't need to have some foundation that's politicized in, you know, where we have the Bitcoin Foundation or the Ethereum Foundation. That's a centralized structure that really deems a lot of the fate of the whole thing, which I don't really like the word foundation, because these aren't really foundations. They're just like, oh, hey, we have access to this many funds, so we're going to sell this much or whatever. It's not about that. It's about putting these into different people that are going to help represent the system and help bring value as a bridge into the outer world, kind of like Kier was touching on a little bit with Nexus software. That's actually going to be acting as a bridge between our debt-based system and then this new prosperity-based system. And that's going to be providing value in software systems. And then the developer keys will be able to appoint it to people that help continue funding the developer, have their own income, I guess you could say, from the network, but also be doing more coding that takes some of that off of my hands so I can concentrate on some of the higher levels and some of the lower levels too, and do some of the things that are more efficient for me to do that other people do, you know, aside. So that's basically how those keys work, and just think about it as decentralizing centralized structures already and continuing that idea of producing value in the outer world. And that's why we kind of came up with the name Ambassador, because it's kind of like we're an ambassador between, you know, from this new prosperity-based system and the old world to create bridges that will allow people an easier entrance and also value to, you know, solve some of the problems that we have in the world.
And how would that help Bitcoin if Bitcoin had reversible transactions?
Well, basically, having reversible transactions prevents you from, because there's two use cases that cause a lot of lack of user friendliness. The first one is I accidentally sent this transaction to the wrong address, but it's a valid transaction, or it's a valid address. And the second use case would be I sent to an invalid, unspendable address, which is where those two, I mean, to extrapolate a little more than just reversible transactions, the two-way signatures requiring a receiver to sign the transaction before it's processed, as well as the sender, that's going to prevent coins from ever being burnt, which is a big problem. I mean, all of us crypto guys know, hey, double check, triple check, quadruple check the address, make sure it's good, otherwise, poof, gone forever. And there's no way to get it back because of the nature of the design of the system. And the reversible transactions come in where, let's say I have an address book and I accidentally send it to the wrong person. I can't ever receive those funds back unless they are a good Samaritan and they say, hey, you know, I didn't get this, blah, blah, blah. So reversible transactions are really, in a simple way to explain it, they're going to help user friendliness because as, you know, more people come in, most people barely can use a credit card or a cell phone or Facebook, you know, let alone this very sophisticated cryptographic system. So reversible transactions is to try to help ease it and also reduce some of the risk of using it, you know, because, you know, putting in the wrong address, big problem. Putting in an invalid address, big problem. We don't want to be like, oh, I made a mistake, now it's gone forever. There needs to be a little bit of forgiveness in the network.
Yeah, and I would also say that it would be kind of important to be able to refuse a transaction. I mean, anything from donations, or if a customer doesn't pay in full or overpays you, you can refuse that transaction. And it's kind of the beginning of contract law that, you know, allows you to be able to have that right to refuse a transaction. Like, you don't want to be, you know, in politics and then get a donation straight from the KKK. So you'll be able to say, hey, I don't want this transaction. You can keep your dirty money.
Exactly. That's what the two-way signatures will allow, is if you refuse to sign to that address, there you go. Just like, I mean, even if you look at some of Satoshi Nakamoto's addresses on blockchain.info, people are putting these messages on there like, hey, give me this. Oh, hey, give me that. And they'll send it for 0.001 Bitcoin, or 1 Satoshi, the minimum they can send, just to spread message of whatever they want. And it becomes some sort of kind of like spamming of the transaction system, which is a little bit useless. I mean, like he said, that's a very good point. We should be able to have power to refuse from certain addresses, or maybe only approve certain addresses to receive from an address, which is all that you will sign for. So, I mean, it kind of takes it out of this one-way street and makes it a two-way street, so we have power on our receiving end as well as people have power on their sending end. That's how the two-way signatures will work. And the reversible transactions are a little bit different. That's going to be, you'll say, hey, I'm going to send this out as reversible for 5 minutes, so if I find out it's incorrect, then I can reverse it and send a void out by that time span. Now, if it gets confirmed by that time span, you know, then it's gone. But that gives a merchant on the other side, too, an ability to say, okay, well, this is a reversible transaction, so it's going to take a little longer to process, but that also gives you a little more ability to revoke your transaction, a little more flexibility, I guess, because once you send a transaction and broadcast it to the network, and a miner puts it on a block, it's done. There's no say, there's no, I guess, checking in that. So, I mean, it gives a little more power to people.
Can you repeat that? Our variable proof of stake model, how you start at 0.5% and you move up to,
so,
you know, 3%.
I guess that kind of goes into the statement that I already wanted to make, too. I mean, the problem with inflation nowadays is it's actually taking value from everybody and lining that value into banks, which isn't a good way to do it. It's pretty much stealing the energy from the energy transferring mechanism, which is money, and putting that energy into somebody. I always say, you know, I have this cup, and this cup could represent, let's say, 1 unit of currency, and I'm the one that pours the water in this cup, but they have a straw in the cup, and they drink a sip off of every cup that we fill up, and that's a problem. So as it slowly inflates, it should be giving value back to the people that are part of that system. I mean, why aren't we getting an interest into our account comparable to the amount they're inflating? Well, obviously, because they do the fractional reserve banking and blah, blah, blah. I don't need to explain it because I'm sure a lot of you know. But basically what Keith was asking about how the inflation rate grows is it's growing based on a value you contribute to the network, because that value is provided for everybody. So the more you contribute to the network in time, as far as it is right now, the higher interest rate grows. And that's what's, started a backbone with trust keys. So it starts at 0.5% and it grows to 3% after 1 year. So that people that are dedicated every day to the network, instead of people that are hopping on and off, should be rewarded the greatest as far as the new inflation, because they're going to be most likely to continue to provide more value into the system from that inflation. So that is kind of how this is all being designed, is to give to people and also give other opportunities to gain new value from the system, where just by simply contributing your time and your computer, you actually gain more, rather than, with Bitcoin, if you run a node year long, you're not going to be rewarded for that. And you're not, when really that's helping to build the backbone of the infrastructure. So they're really running a node just to help the network. But I think that the people that are helping should be rewarded in a reflection to that, rather than it just being, somebody continuing to take a straw. And there's somebody else, helping add to your cup instead of somebody always taking it.
Yeah, well, that was very
Okay,
interesting.
well, let's hop back on the questions for Colin.
Yep.
Okay, there's 7.4 billion people in the world, and only about 5 billion have access to banking. Yet there's about 6 billion people that have access to cell phones. How can we reach those 6 billion people, which is a growing number every year, to have them possibly use Nexus over any existing financial service?
Well, obviously a lot of the world uses cell phones, so, while it's on those cell phones using kind of light nodes that, work with the trust system, they'll essentially be able to help in the, distribution and the processing and the validity of transactions. So the light wallets can really use very few resources on cell phones. But also, we're going to want to look into different infrastructures too, as well, beyond just, how do I say it, cell towers and, ISPs. We're going to really want to start looking into a better communication system on the hardware levels, let alone just the software levels, where, we're starting to break into quantum superposition, which can give us really, really high bandwidth communication systems with distance not being a factor, or optical communication with, infrared or ultraviolet. Most likely you probably want higher intensity, higher frequency waves. So, it's really, it's utilizing some of the cell phone infrastructure, yes, and some of the internet, yes, but really, it's, we got to have a new system. Instead of trying to wire up the whole world, it's, we got space right up there. It's not that far, into the low Earth out orbit, which, running some CubeSats, running some decentralized nodes up there, we can start to bring, I guess, the future, which is already pretty much here. It's just not built. We have all the pieces. We can to provide value for people, like the people that have cell phones. Personally, I don't think we should ever have to pay for cell phone service, or we never have to pay for internet service, different things like that. Those are just constructs meant to tax us further and centralize our communication with one another. When, as we start to expand our hardware, let alone the software that's going to run on that hardware, we're going to be able to provide that to a lot more people. And they're going to have access to the banks. We can help to start bridge that with the 2 billion people. There can be banking services created with the service templates on Nexus for people that want to create their own trust algorithm or whatever. It's just, we got to provide people as many options as possible. And, the way we do that is by making it as accessible as possible for everyone. So it kind of helps level the playing field, instead of it being, well, I was unfortunately born in this location, so my internet service is not very good, and I have to wait for it to be here. Or I can only use this internet service provider, which is very well known for spying on us, or whatever else. It's just, there's some fundamental, constructs even lower than, the lower level programming, but like I was saying, to the hardware that we can, really start to improve to make it easier for people to just do what is natural, which is communicate.
Explain to us the CubeSat idea. If we have any possible relationships we can build to make such an idea of launching a cube satellite up, or a bunch of cube satellites up into space, and then broadcasting the blockchain down to Earth.
Yeah, well, I've already spoken with my father, who he's, an aerospace veteran. I pretty much grew up in the aerospace industry, with, meeting certain public figures like Carl Sagan and Bill Nye and the Planetary Society, among others. But, so there's a lot of connections that I have just through family into that. And he started a new space company. He was involved in the starting of SpaceX. Elon Musk came to him to, get plugged into the aerospace industry. It was Lou Friedman from the Planetary Society who recommended my father, because he's an expert in a lot of Russian systems and a lot of internal NASA things. So basically, I've spoken with my father about this, and he's interested because he's actually starting a company to send up CubeSats, and he's really kind of behind the idea. So that's going to be something in the next few years we're definitely going to be putting into action, and that's where some of the ambassador key ideas come in too. Is providing that to his company specifically will be able to pay for the launching, which I think it was a couple million per launch to put up, I think 10 to 20 different CubeSats, which that will be our first step, to decentralizing the internet, is actually putting nodes in space, which Jeff Garzik was the only figure that was actually thinking in that direction. But now, that's a great possibility. I mean, not even a possibility, it's happening. I mean, I've gone to the rocket shop and seen them. I actually worked with John Garvey, who's his business partner, back when I was 16, building rockets for him. So I already know them very well, and that's definitely going to be something that we are going to be moving forward with in the next 2 years.
Can you comment on, what features you're intending to work on next, as far as with the currency, and where that's going in the near term?
Yeah, well, currently I'm getting the trust deprecation, sorted out, which is, I'm not going to have trust keys expire anymore, because, that's just, that algorithm worked, and it was a good idea for a point, but it's just become, it's very difficult to maintain a trust key. So, I mean, I'm going to reward certain people that still have an active trust key before this time lock they're going to be a special, not really having any special privileges, but they're going to be colored a certain way, so that, we can know, like, okay, well, these are certain very dedicated people that have maintained a trust key before this time lock. Now, other ones, they're just going to be non-expired, so you'll be able to pick up your trust key and, build it off of the trust. So I'm going to do, basically a grace period of time since your trust key was expired to the time lock, which in simple words is going to say that time will not matter as a deprecation or a depreciation of your trust. And then after that, your trust is going to depreciate if you don't contribute, but it'll appreciate if you do contribute. So that gives people a little more wiggle room, and that's kind of been a consensus of what everybody has wanted. Now, on top of that, the lower level database, that's very close to being finished, and also redesigning the indexing system with, I don't know if people know on the code level, but, blocks are indexed in a certain way with, it's, what is it called, a binary tree. So, it's actually a linked list with pointers. But anyway, I'm changing that whole too as well, because it's kind of an inefficient system. And then another really big thing I know is the wallet. It's an ON algorithm. It's very, very, I don't want to say the wallet GUI. It's more the wallet code, how everything's managed. Like, your keys and your transactions and everything are all stored right in your wallet.dat. Now, that's really inefficient, let alone, I mean, you get more transactions. Why should those be stored with your keys? Your keys should be over here. Your transactions should be over here. And they should be accessed and indexed in a more efficient manner, because once you start getting to 100, 200,000 transactions, it kind of slows down, because it's adding to a giant list and everything like that. It's not properly designed. I don't want to speak negatively of it. It just wasn't designed to scale. And so as I've done load tests and different things like that, I've noticed a lot of weaknesses in certain points. So those are the directions I'm started at right now. And, you know, eventually as it grows more, I'm working on, you know, infrastructure with the Merkle chains and the transaction grouping and transaction locking, which is going to give us pretty much very, very efficient, fast transactions. It's similar to how zero time or instant X works, but it's done in a completely different way. So it's basically going to have transactions that are validated by certain nodes, and then these other sets of nodes will be validating those groups of the transactions, and then the miners will be validating them. So that will be a check and a balance system. So they all three will check each other, and instead of the user having the power to say, I'm going to generate this transaction at this timestamp, they're going to have to broadcast their signature, their input, and their amount, right? Those are the only three things that somebody should ever have to provide for their transaction. Oh, and also their output address, and then the network will pass that around through these transaction nodes, and as they pass that around, once they all agree on a timestamp, then they'll lock it in at that time, so that then that will be a zero confirmation lock transaction, which then will enable other nodes to start grouping that together based on, you know, an algorithm for time span, which then they include those and blah, 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 and those handle that, which we're going to actually transition Nexus proof of stake to be for, and then eventually into the miners, which are going to validate the Merkles, and the Merkles will validate the transactions. And then the everyday person that's creating a transaction will have to be validated by the transaction network. So this way, it doesn't give power of transaction processing into one hand, but through those checks and balances in the lower level voting with, you know, the blocks and the Merkles and the transactions, that's also going to be providing a higher efficiency and a higher scalability.